Power quality issues cost industries billions every year, and most of them never get properly diagnosed. If you work in the field, you know the frustration. This podcast is for you. Welcome to Power Quality Decoded, brought to you by Power Monitors Incorporated. Find us at powermonitors.com.
Hello everyone, and welcome to today's white paper webinar. And today we are talking about a feature in PQ Canvas supported by the Bolt, the Seeker, and the Guardian to allow you to simultaneously look at line-to-line and line-to-neutral voltages. If you have a three-phase recorder connected as a Y, where you're measuring each voltage from phase to ground, or phase to neutral, you can now, in the recording, without any extra effort, also look at line-to-line voltages. So you can see the Y view and the delta view in the same recording. And that's important because many PQ standards, for example, voltage regulation, voltage imbalance, harmonics, and flicker, all require or assume a line to neutral hookup. Most services are a Y hookup, and most PQ metrics are meant to be applied line to neutral. But customer equipment is usually connected line to line or phase to phase. So you can either look at the service voltage as the utility is delivering it and as they're measured by, or you can look at it in terms of how the customer equipment is actually seeing it. But with this new feature, you can do both in the same recording. If you have a Y circuit, you connect the recorder line to neutral, and then the recorder will record those voltages as it always has with strip charts, with waveform captures, with histograms, and daily profiles. But in parallel, it's computing a second set of voltages. It's computing the line-to-line voltages itself in real time by doing the math to subtract the neutral out of the equation. So that gives it a parallel set of voltage stream data, and it's also recording strip charts, daily profiles, and histograms of that second set of voltages. So you really get two sets of three-phase voltage streams in the recorder itself, the normal Y or line neutral stream, and also the line-to-line stream. Now with waveform captures, the recorder doesn't actually have to do anything. Because the raw waveforms are available, the software itself, either PQ Canvas or ProVision, can compute that for you. But the strip chart where the data has been reduced to RMS values is a different thing. That has to be done in the recorder itself. A Bolt or a Seeker can do this automatically. And with the Guardian, of course, the Guardian is a single-phase recorder, but with the Guardian, the recorder computes the 240-volt line-to-line voltage across the transformer. So the Guardian traditionally will record line to neutral on two channels. With this enhancement, the Guardian will create a third channel that is across both 120-volt legs, which it generates by subtracting the two voltages on channels 1 and 2 on an instantaneous basis. So I'll hand this over to David Keaton, who wrote the paper to show how you do this in PQ Canvas. Once the data is in PQ Canvas, whether that's through streaming directly with a cell network or Wi-Fi, or whether you've downloaded it with PMI view on an iOS device or a laptop, once it's in PQ Canvas, you can then take advantage of this new feature.
So here we have a reporting for a Seeker. You can click RMS voltage here, which will bring up a strip chart trace with both the RMS current and RMS voltage. Navigate down here to the bottom toolbar. You'll see the icon for Y delta voltage. You can change it from phase to line. Here we'll change it to line. And we'll see it shows just 3 channels of RMS voltage. Let's see a couple other ways to navigate to it too. Go up to the interval button up here in the graph row. Click on Basic Overview, RMS voltage would actually just give us the average traces. Click Line, change over to the line-to-line measurements. Click Phase, change back to the line-to-neutral measurements. You can also view this in daily profiles as well. Click RMS voltage. Simply toggle to line here as well. And back if need be. Couple of places we can take a look at our histograms. See that the view changes a good bit because the 4th channel isn't taken into calculation for the minimum and maximum edges of the histogram.
Then you can see just at a fundamental level, you're getting this is 208 volts phase line to line. You can see the histogram clustered around 208 volts, and then in the other mode, it's of course 120 because it's a 120 208 service.
Waveform captures is another place that we can take a look at. Let's take a look at a specific waveform in this recording. Here we can see by toggling on the delta voltages, waveform traces are in comparison to each other instead of to a neutral.
Yeah, and this is a key aspect here because most customer equipment is going to be connected, as a delta. So what looks like a single phase to ground fault will be presented on two phases. In fact, as you can see here, if you switch back to the normal mode, we see a dropout on channel 3 here. So this is the single phase line to ground fault on phase C, but that's not how Delta connected equipment is going to see it. If you switch back to Delta mode, now we see what a piece of equipment is going to see, and you can see that it's affected both phases. And if you click on RMS up there, now we can see a continuous RMS graph of the same thing. We can see what each phase-to-phase voltage dropped to. So if we have the cursor hover over the worst case here and turn on the marker, so now we can see the voltage drop to about 150, 160 volts, 145 volts roughly on two of the phases. One phase is still about 200 volts. But if we click back to the normal mode, you see a much different picture. In fact, you see an increase on one phase because the voltage swell on phase A when looking at line to neutral, because as the fault current flows on the single line to ground fault, the other two phases actually increase in voltage from looking at line to neutral. But again, that's a much different picture than the equipment seeing. So here we have both views available. The view from the utility standpoint of what are they delivering to the customer, and the view from the customer standpoint, what is my three-phase equipment actually seeing. So again, in the waveforms, this is computed by the software here on the fly because it has everything needed to do that. In the strip charts, when you look at this, that's recorded by the recorder itself. So in the strip chart, you would see swells on two of the voltages and a sag on the third voltage. And if you switch to Delta, you would see a different story. And as David showed, you can also have information in the daily profiles and histograms for say voltage regulation or other needs. This is important if you're looking at voltage regulation because, again, equipment is looking line to line, and the utility is usually controlling their voltage regulation on a single-phase basis, line to neutral. So it's important to have both views in mind and be able to see both in the same recording, and this new feature allows you to do that. So, for example, here is the waveform capture. So we see a swell on two phases, two channels, and a sag on the third, which is what you'd expect from a single line to ground fault. If we switch to this other mode, now we see a sag on all three phases. So this is what the customer is going to see, a three-phase type 2 sag, but this is what actually happened from a utility standpoint, a fault on one phase and a swell on the other two phases. So if the customer has single-phase connected equipment, or one of these phases is also a single-phase lateral, you're going to have swells on two phases and a sag on the faulted phase. But customer equipment inside a facility is going to see a much different picture. It's going to see just a voltage sag across all three phases. So this feature allows you to capture both effects in the same recording for the same event. Well, that about sums up the paper. If you have a question later, give us a call anytime at 1-800-296-4120 or send an email to support@powermonitors.com. Thanks for attending, everyone, and everyone have a great day.